All right, so I'd like to talk about integrating CakePHP with GraphQL. So I hope everybody can see my screen. I cannot see chat, so I hope everything runs. So let's start with a few words about me. So I'm Daniel. I'm a software developer, and I see a chat here. Let me quickly open it. Yeah, great. You can see my screen. This is wonderful. So I'm a software developer. My first PHP contact was around in 2008 with, I think, 11 years. And my first CakePHP contact was when I started my job at this agency in 2015. And I've since then worked with probably every version since the 1.3 or even 1.2. I don't remember correctly. And in my free time, I'm a volunteer at the German Red Cross and a bass player in a heavy metal band called Tomb of Giants. So since Paul did a shameless plug with his band, I'm doing it too. So another shameless plug, I'm here on behalf of my employer, which is Interweber. We're a digital agency founded in 2009. We're sitting in like the northwest part of Germany, and we do all kinds of stuff. We do websites, e-commerce, custom web-based software. So everything you'd like. And yeah, in the custom web-based software, we tend to use GraphQL, which brings me to the next point. Why even use GraphQL? REST is fine. And you're probably right. We've seen in a talk earlier that there are now tools like Swagger, which make this slide more or less obsolete if they work correctly. But a common problem with REST until now was that you don't really get type safety. So the response you get from a REST endpoint is more or less arbitrary JSON, on which you may have agreed with your backend team or which you have built yourself while building the backend. But you don't really have, sorry, you don't really know what is coming back if the server changes, for example, and you forgot to update the client. And the same applies to the request parameters and a string. Those can only be strings or even JSON. So what you can do to play with that is when you get back your REST response, you can push that into a validation script and check if everything's there where it should be, and then cast to a type, which you can see on the right more or less. So you're casting the code, the response object that you're doing to a type to-do list where it's so that you can work with a proper type. But the problem with that is that this validation and typecasting and stuff only really helps you at runtime and not at build time. So should your server return something else that you do not expect, only your users will notice, and then you will notice in your error logging tool like Sentry or something. So now that's the point where GraphQL comes into play, because GraphQL gets you some cool things that will help you with that. So first of all, you get a type schema, which is pretty similar to that JSON structure that the other speaker showed with Swagger. You get a schema which you can at any point interpolate from the server. So you can send a special query and you get that schema back, and it tells you which queries you have and what parameters they take and what they return. And everything is strictly typed. So for example, here you can see we have a type query, which defines our queries, and we have an identity query, which gives us a user back. And on the bottom side of the image, you have the type for the user, which is an ID and a name. So you know you get an ID and a name back if your query tells the server to return these fields. And of course, the fields themselves can also get parameters, which is useful for pagination wrapping stuff, which we will get to in a minute or a few more. So another concept of GraphQL is that you have queries and mutations. So you have your query, which fetches server state, and your mutation, which obviously then mutates server state. So what you can do is what I've already told you. You have queries which have defined return types, and you can select which fields you want from that return type, much like an SQL query or something. And you can then also put parameters which can be required or optional. And yeah, the server also always tells you if it's correct or wrong. And yeah, the same applies to mutations. The only difference is the name, so you can differentiate between queries and mutations, much like a get and post request, if you wish. So the principle is the same. You have input types, output types, and you can do subselects in the output types. And speaking of the output types, often you will find yourself selecting the same fields for one type, because you have like fetch single entity, fetch all entities in the pagination, create entity, update entity and stuff, and you always select the same subsets. And that's where fragments come in to keep yourself dry. So you don't repeat yourself. You define a fragment and say, okay, I want a field ID, title, and content. And then you can reuse this fragment in your pagination or in your mutation or in everything that gives you that return type back on which you on what you did define this fragment. So right, after we've done our homework and wrote all our queries, what do you get? So you actually get a hook per query that you wrote. At least in our project, we have a thing called GraphQL CodeGen, which will scan your files and check for queries and then throw you hooks. And you can then use this hook to fetch the data. So your only touching point between the server and the client is your GraphQL files on which you define what the client wants from the server. Yeah, that's pretty great. And then your really front-end team doesn't have to think about the server stuff, because they only say, okay, I want this GraphQL query, I want to fetch, I don't know, something, and then stuff in that, and they get exactly that in this const that they get from the hook. So they can focus on building the front end and not about connecting to the server. So now we get to the part that you're all here for, GraphQL and PHP, because GraphQL was in the past more of a JavaScript thing. At least for me, it seemed like that. So in a sense, to integrate with CakePHP, we use two libraries. The first one is WebOnix GraphQL PHP, which is the basic server implementation in PHP for doing a GraphQL server. This is pretty major, it works well, but you have to define a schema, the thing that I showed you in one of the first slides. So that the WebOnix thing knows which types you have. And this is exactly where GraphQLite from the coding machine comes into play, because this thing can build you a GraphQL schema from return types and annotations. And you can see on the right hand side some images or some code snippets which show how this works. So you may have a GraphQL controller like the to-dos controller, and you annotate your function with #query. You then define the arguments that you want, which will be actually the arguments for that query, and you define a return type. And this will yield exactly the query that I showed you in the slide earlier. It may be in a slide after this one. So it will yield a query that takes an ID and gives you back a to-do. And on the bottom, you see the type definition for a to-do. So you have like your normal entity class, and you annotate it with #type, and then you build functions to get values. And then you put there a field annotation where you can optionally put a GraphQL output type, which is useful for this ID stuff, but you don't have to. It can be inferred from the return type, and this will create a to-do type, output type, that has an ID in the title. And the content is also in this image, but I had to put it like very down low, so it's cut off. And then to do your mutations, you define factory types, which are basically just a method that will return the type that you want as an input type. And you define the functions, sorry, not the functions, the arguments for that function, which will be the fields for the input type. So the GraphQL user can then just throw you the title and the content, and you will yield an entity. And we will have a brief look into that later. We'll have to look a little bit on the time today. So now really integrating with Cake. We've talked about what is GraphQL, what's the value proposition, at least for me, and how does it work with PHP in general. But we're at Cake first, right? So we want to talk about CakePHP. So before we get to the good stuff, we have to do some chores. We have to adapt the moving parts like authentication, authorization, pagination, and we have to wire up a direct injection container because, yeah, we need that stuff for the factory stuff and so on and so forth to work correctly. So you can see on the right-hand side some things that we get from doing these chores. So first of all, you get this hashtag inject user, which will query the authentication service that we have adapted and give you the user that is in your, or the identity for a lack of a better word, that is in your authentication service and throw it in a function, because obviously this is GraphQL and you don't necessarily have access to the request there. So you have the user here and you can do everything you would have done with this authentication get result, but you have it directly here. And by adapting the pagination, you only have to return a new cake or pagination result, throw the query at it, and you're fine. This thing will take care of returning you this count and items type and taking offset and limit so that you can do pagination in your client. Everything typed. So now that we've got the chores out of the way, we still have to do one thing, and that is the following. As you can see on the very left image here, in GraphQL, you can directly query the association. So think of it this way. You have a to-do entity, and this to-do entity has an association on the users. So you can query the user. And a user has an avatar, so you can query the avatar. So a common way in GraphQL to do stuff would be, okay, I want to get the to-dos, I want to get an ID, title, content, whatever, but I want also get the user, the ID of the user, and its avatar, and the URL of the avatar. So we would need a way to tell the CakePHP ORM to actually fetch that stuff. So what actually happens is the GraphQL Lite thing, or yeah, I think it's the GraphQL PHP thing from Web Onyx, creates a resolve info object from the user input. And from that, you can get a list of selected fields that the user requested from us. And this is just a plain string PHP array. And we've built a mapper which takes a query, and it takes a user, an identity, and it takes this list of fields, and it then will modify the query to contain the required selects. These are the fields the user selected, as well as the required fields for so that CakePHP can actually build the association queries. And it will also contain the contains. And actually, this is still secure because we're using the authorization plugin of CakePHP. You could use something else, but we have a deep integration with that currently that applies an authorization scope for every contain and for the top query when you put it through this mapper, so that the user can only query stuff that he is allowed to see, at least according to the scopes. So, oh yeah, let me shortly skip that slide. What do you have to do to set things up with CakePHP and GraphQL? Well, first of all, you have to bake your migration and models. So you build your stuff like you normally would. You do your migration, create the tables, bake your models out. Then you go ahead and annotate the models. So you put an hashtag type on top, and then you annotate the fields which you want to be available in GraphQL. You then build factories so that you can get each model from GraphQL, so that the user has a surface that they can create the model from. Then you obviously build policy classes for every entity and table. This can be quite a chore, but in the end, you would have to do it anyways, because somehow you have to secure which data the user can access, no matter if you use GraphQL or not. Actually, there was a talk yesterday which showed this pretty nicely. So if you haven't seen that, check that out. And then in the end, you have to create a GraphQL controller for each model, which gives you the basic create, update, delete, and read stuff. So I skipped the slide earlier, which is virtual fields, which is a common use case. So you may have a user class which has a first name and a last name, but you may want a virtual field full name. And because we are only selecting the fields that the user requests us, we have a problem because, well, if the user requests the full name, we don't load the first name and last name from the database. So what do? We put another annotation on the function which says, okay, I'm dependent on the following fields. And the fields can be fields on the same model or on my associations, actually. And then those fields will be queried. And if these fields themselves define dependencies, because you may have a first name function that also has dependencies, those dependencies will also be loaded. So in this case, excuse me, you have the following case. The user requests the full name. The mapper will then go ahead and request the first name and the last name, and will then check the first name and sees, all right, the first name requires the first name and the middle name. So what will then happen is you will get the first name, the middle name, and the last name, which are all available here. So you can very well do virtual field mapping. The mapper can handle it. So as said, we still have to build a controller. And I try to make that as simple as possible by, well, providing a base controller on which you only have to throw basic fields. So you have basic routes like fetch entity by primary key, fetch entities, create entity, update entity. And what you do is you define, much like in normal Cake, the model that your controller uses, and you throw in the stuff and you annotate the types. But the real logic, which will be repeated every time, is in the base controller. And if you should need to override that, you could, but you don't have to because it's all there. All right. So now that we've talked about that, I think I'm relatively good on time, so we can have a quick look into that stuff. So right here, I have my demo app, which is just the plain to do app with the title and the content. And I will also shortly fire up Postman. And right here, I will refetch the schema, see if it works, and it works. So we have our query, we have our to-dos, which we will query. And then let me just quickly remove this, and we'll just query the count so that you can see what happens. If you then send this query, we'll get back an answer, and it says count is 0 because we have no to-dos yet. So what we can also do is we can query items and then say we want like an ID for each item. And items is currently an empty array. So what we could then do is we could post a mutation, say we want the mutation create to do, and we will send a to do, which is just a plain object, and this will receive a title, and it will receive a content. And you see, even Postman knows the schema and tells me what fields I need. So I'll just do test and test maybe, and then I will select the ID from the result. And if I send this, I get back create to do, and we have created a to do with the ID 20. So if I now go back to my query, I actually get back to do's, we get count 1, and we get our item with ID 20. So because the ID itself is boring, we'll also select title and content. And this gives us the thing that we just created. So now this is not everything we actually need. We may want to do filtering, and I've left that out in the presentation because I thought I was pretty short on time, but I think I have about 10 minutes left, so I will quickly jump into that. The get to do's, so the fetch entities thing actually supports filters and sorters, which allow you to specify the way that the query is handled and filtered and sorted. So now I've just put a filter here, which is basically just a class that we provide, and you do a factory for that. So it's an input type. And then you throw it the field name and then a matcher. And the Melchior itself is just a class that you can build. It's an input type itself. As you can see here, here's a factory, and you can put different stuff. And then the Melchior will be built on the query and match different stuff. So what does it look like if you use it? So we can tell our query that we want to use a filter, and we want to filter on title, and we want it to contain title. I think I have a typo there. So this. So now I obviously get the same result because I put the title there, but I could also go like starts with, and I will put an E because it doesn't start with an E. And now I do not get this item anymore. So you have a very good way of building your stuff and giving your front-end team a constrained but completely typed way of working with the data without you needing to think about how they would use it. You just throw them stuff and they can then flexibly work with that. So now just a quick look in the app. I will reload once. So we have here the title. We'll just add another one for testing purposes. It appears here. We can check it. It will disappear because check is just a delete. And yeah, that's the thing. And this is more or less everything I had in my talk, I guess. Yeah. So I was a little scared that I would not make it on time, but I guess I have some minutes left. So if you have questions, please feel free to ask them, or if not, you can also ask them later via Slack or email. Please use the email here. It's cakefest22@damdaniel.de, and I will be happy to answer you.